I'd like to welcome you to our June webinar on using GPS and GNSS Part 2. So this is a three-part series. We started this back in May, and we looked at converting or calibrating a local survey to the GNSS coordinate system. In Part 2, we wanted to work with the GNSS in a 15-lot PUD survey that does not use the same CRS as the GNSS. The survey CRS was used in the design and engineering of the project, so we don't want to change it. But as we'll show you, Traverse PC works beautifully between the two coordinate reference systems. So I want to drop in right away and talk about this TPC RTK N-trip solution and kind of why we're pushing this in this release and kind of the parameters of that. So let's take a look at that real quick. If you drop down to the bottom of any of our web pages, there's a unified help system, and I'm going to open that up in a new tab. And one of the sections you're going to see that's new in here is using GPS and GNSS. And right off the bat, we see that we talk about selecting a coordinate reference system. So TPC transforms geodetic positions from GPSS into coordinates and vice versa via its coordinate reference system. And geoid modeling can also be used with this. So that's how we're going to get between geodetic positions and coordinates based on whatever your projection is. We're going to be using the NAD 83 Oregon South state plane today. But once we've got that into coordinates, then we need to say, how am I going to coordinate that with either a survey I've already got put together at 5,000, 5,000, or a survey that's using maybe a low distortion zone, and I can't use that zone with my GPS equipment, or whatever your reason might be. I run into this all the time when I'm just entering record data. And I'm going to enter the record data at 5,000, 5,000, or 00, and I don't even know where it is in the real world, global position-wise, because I don't have anything around it to tie. So I'm going to actually calibrate that using my GNSS equipment with a workflow that we covered in Part 1, and we're going to cover that same workflow in Part 2 today. And then I want to come down real quick and talk about using GPSS and GNSS with survey data. And that's why we're going to be talking about this calibrating. Now, I mentioned in the outline of the webinar here that we're looking at this RTK N-trip solution. And if you'll give me just a couple of minutes to kind of talk about where we're going with this. So a number of trends are converging to open some great new opportunities to use TPC with GPS or GNSS, like the solution shown here. And this is covered for you in Part 1 of our GNSS series here. Now, let me drop out real quick and show you how to access that. If you go to our member area on our website, in the Learning Center are all of the recorded demos. So on that recorded demo page, you can drop down to GNSS, GPS. Here's using the GNSS with TPC. So this is what I'm going to just give you a real quick overview of real quick here, kind of what we're looking at for the system. And then you can also come back out and look at this convert a local to GNSS CRS. And this is the Part 1, where we actually dropped in and said, okay, how do I take this local 5,000, 5,000 survey and calibrate it so that I can use it with my GNSS equipment on the same coordinate reference system as the GNSS equipment uses. So that's a 26-minute video. The introduction is about a 29-minute video. So you can watch those in an hour. And I think it's important for you to kind of get a handle on it. But I want to drop in and just talk about this real quick. So what's changed in all this? A solution like this wouldn't have been possible even a few years ago, but a lot has changed. One is that GNSS now comes with L1 and L2. So we had L1 with the course acquisition at 1575 megahertz. We've recently gotten all the L2 at 1227, and that has brought in a lot of satellites. And we're kind of watching the L5, which is the new band, primarily used for first responders and aviation, but that may become available sometime also. So basically, I have satellites 24/7. That's kind of what that amounts to. We have better cell phone coverage in the field. The solution we're talking about today requires a hotspot for real-time corrections via an N-trip network. We have better N-trip networks and free casters, so I can actually create my own device and a mechanism to send corrections up to the cloud. I don't have to rely on those from the N-trip network. I have better GNSS equipment and prices. I have better and free mobile desktop apps, better and free use of the World Wide Web and cloud for data. And we're going to talk about some of those. So I'm using this particular solution. I'm using Traverse PC with TPC Desktop 2023 R1 on a laptop. And in this release, the R1 release, we're focusing on these workflows I'm going to be showing you today and putting in lots of tools and efficiencies to make those workflows just kind of flow. I mean, it's really fun to kind of work with these now. We've got a cell phone with a hotspot. I'm using an Android Samsung S10 in this particular case. I'm using my range pole and bipod that I've had around forever. And I just put a clip on it to hold the phone magnetically so I can lift the phone on and off and use it as my phone because I still am taking calls and sending text and everything else, and I want to keep it out of the rain when I can. Or I can just set it on that mount with the magnet and it just holds it there when I want to hold the rod and level it up. Pretty easy. I'm using the ORGN, which is the Oregon Department of Transportation N-trip GNSS network with my password and login. And then I'm using this EMLID Reach RS2 Plus. That's this device here. EMLID has this in an RX. This particular device allows me to hook up an antenna and use long-range radio with a second device so I can have base and rover. It also will data log. So I can log data and do Opus corrections with a Rhinix file. And the Oregon N-trip network also will allow me to pull Rhinix files for the same time period that I'm data logging with the EMLID. So I actually, if I want to post-process, I only just need this one device. If I want real-time and I don't have cell phone coverage available, then I need two of these devices. I'm just going to focus on the one device for this webinar again today. And then we're going to use EMLID Flow, which is a free mobile app that runs on Android or iOS. And then we're going to use EMLID Flow 360, which is a free web app. And it's one of the reasons we've kind of settled on EMLID or focused on EMLID is because they've got kind of the full range of pieces we need to make this all work. And they're not going to do what you could do with a $50,000 or $30,000 system from Trimble, let's say, all by themselves. But when we put their equipment with what Traverse PC can do, we think we've got most of the bases covered. And that's really what we're doing with this 2023 R1. We're kind of pushing that. We said, let's see how far we can get with this really inexpensive system. So we spent $2,600 is all. And we've already got Traverse PC running on a laptop. We already had, total station equipment like the bipod and the range poles and all that kind of stuff. We just added our cell phone and the N-trip and away we go. So this is the system we're going to be working with. And everything I'm going to do with this system. And again, we can extend it with a second receiver and do base and rover and accomplish the same thing when and where we need to have that capability. Let me mention one more thing about this particular solution that I'm going to show you when we get to working on it. And that is that as I collect data in the field, that data, if I'm using a hotspot, shows up in the cloud. So real time, or within a few seconds, I have access to that same data back in the office with the EMLID Flow 360. So I can send a field person out and actually watch what they're doing real-time data collection and text them and say, I need you to go a little bit farther west of the property line to pick up some additional topo points. Or I need you to go out and pick up the center line of 9th Street from Ivy to Oak. So I've got a baseline on that. So it's kind of a pretty neat, almost like a futuristic thing that we've wished we had for a long, long time. And with this particular combination, I get some extra benefits like that. So let's come back again and frame this for you. In part one that we did back in May, we talked about converting a local survey to the GNSS CRS. And we used an example of a site survey that was at 5,000, 5,000. We did the same field workflow to calibrate that 5,000, 5,000 local survey with the GNSS CRS, and then we converted or calibrated the whole survey up to state plane. Okay? And that's sometimes a really efficient way, because now I'm just dealing directly between my survey and GNSS data without any calibrations, because they're both on the same coordinate reference system. Okay? Some of you are able to start a survey because you've got known monumentation out there with GPS or GNSS positions, and you can just start a survey. So you would never have to go through that process. But this is if you've got any kind of backlog of surveys that you want to start using with GNSS, you're going to be right here. Okay. Now, that was part one. Part two, remember I said this is using GNSS with a local survey, and we're not going to change the coordinate reference system of our local survey. We're just going to keep it where it is, but use GNSS. Now, I'm going to change up this outline a little bit as we go, and I'll show you why here in just a moment. So let's go ahead and introduce you to this project so you can kind of get familiar with what we're talking about. This is a 15-lot planned unit development, PUD, that we brought online back in 2007. So we worked on it 2005, 6, brought the lots online in 2007. There are now, I think, 4 lots that haven't been built, and 2 of those are getting ready to build. So it's just about built out, and we've done some additional work out here a number of times. And I've got 3 projects that I'm working on now out here, and we're going to walk through a couple of those in this webinar here. So let me come to the drawings and just show you that in addition to page 1 and page 2 of the plat that we submitted, okay, all of us at 5,000, 5,000, we've also got as-builts that we've submitted to the city. We've got all of our preliminary planning stuff that we did to get approval for this, and we had construction drawings done in CAD for the streets, the sewer, the water, all at 5,000, 5,000. So I certainly could convert all of this to the same GNSS coordinate system, but I don't want to. I've got too much work invested in this and too many files that I would then have to, if I ever went back to one of those construction drawings or one of those as-builts, I'd have to make sure I was calibrating right properly back and forth. I don't want to have to do that. I want to keep all that world the same and not mess with it. But I still want to use GNSS out here, because I have to admit, with this system that we've been working with, it's kind of like falling off a log. I mean, this is the easiest thing to walk out there, turn the receiver on, and I get a fix, and I start surveying. It's just super, super simple, and I think kind of fun. So I want to be able to use GNSS with this instead of dragging out a total station. Also, quite a bit of the work I'm going to be doing is in the brush. You're going to see kind of what that looks like here in just a minute. And I don't have to cut line of sight. With the L1, L2, I can get a fix under some pretty thick stuff. And if I can't, I can set up a base station and a rover and let the radio send the corrections with the base right out in the wide open space. So really, there's no reason for me not to go work with this in GNSS. So that's why I'm going to keep it the way it is. Now, I want to jump in and just do a couple of things with you here so that you can kind of see how this works and where we're going with this. I've got a drawing in here, let's open these up, that I've called a GNSS export. And I want to send back out the line work, the monuments. I need some of the street monumentation in here. And I want to show you what this looks like. This is all at 5,000, 5,000, but I'm going to come in to my survey information, and I've got this set up for NAD 83 Oregon South because that's how Traverse BC converts geodetic positions to state plane coordinates. Okay, but I'm going to come in and open up or use this calibration that we're going to create here in a minute, and I'm going to say I want to use that as a site calibration, and I want to calibrate geodetic points. Now, it's going to do that automatically, okay? And if I were to come back to press F1 here and go into site calibration, I can see that Traverse PC is all set up to handle a lot of this calibration pretty simply, okay? In fact, a lot of this is going to happen without you even thinking about it. So I can work with these local coordinates, 5,000, 5,000, and Traverse PC is going to calibrate or reverse calibrate as needed. I'm going to show you the first example of that here. So let's tell Traverse PC that I want to look at this 5,000, 5,000 survey in Google Earth. So I'm going to say File, Export. Let's not send the entire survey. Let's send just the 18 items tagged in the Traverse Manager. So if you go back here, because I brought up this drawing, I've got certain traverses tagged. 15 of the lots, I've got 2 of the streets tagged, and I think I've got, yeah, the boundary tag there. So I'm going to send just those traverses to a KMZ file. Let's browse to the folder here, and I'm going to send this in the GNSS just so I can kind of keep track of that. And I did it earlier, but we're going to overwrite that. So yes, I want to overwrite that, and I want to export that. So Traverse PC has exported those 18 traverses. Let's go ahead and open that file up in Google Earth and just see what we got out of it. And let's go ahead and open that file. So there's the lots KMZ that we just exported. And Traverse PC took that site calibration and it calibrated all of that data, actually reverse calibrated it to geodetic positions and brought that in then for us inside of Google Earth. And we've got the monuments, the lot lines, the street monumentation, everything in geodetic positions so we can look at it inside Google Earth. And Google Earth photos are sometimes right on, sometimes they're a little skewed like this. The coordinate positions are right. I just don't always get a perfect image behind it in Google Earth. So I want you to see then that right away, Traverse PC says it's okay for me to work in 5,000, 5,000 and keep everything in 5,000, 5,000 because the calibration knows how to convert between the two automatically for me. I never even had to select a calibration for the KMZ. It just took care of that for me because I had the site calibration turned on. And that's the important piece of this, is that I can continue to work in my local coordinate system for the survey, but I can communicate with and share with another coordinate reference system. I just showed you Google Earth. Now let's drop over and talk about that other coordinate reference system being my GNSS coordinate system. Okay, so let's go ahead and export this as a shape file to EMLID so that I can go out and stake out these lines for the common area. And I don't have the wetland in here, but I would do the wetland delineations the same way when I finish staking out the wetlands there. So watch what I'm going to do. I'm going to right-click, say Tools, Export Drawing As. Now I'm not going to, well, I guess I could. I'm going to choose the 18 tagged items in the Traverse Manager. I could send the drawing too, but remember this is what we sent out earlier to Google Earth, so I want to kind of be consistent with that. Let's go ahead and expand those lots. You can see those are the lots, those are the streets, and here's our boundary that we're sending out. Okay, so we're going to send out the 18 tagged items. For our shape file, we're going to write those as polylines, so each lot is going to be a shape. That's going to help us. And then originally we thought we could just export geographic, the latitude and longitude of those points. EMLID doesn't read those as far as we can tell. So we're going to write a projected, which is going to send the coordinates, but it's going to include a projection file so that the shape file reader, whoever's going to import that, knows where it is. So let's go ahead and OK that. Let's create or select a file. And I'm going to go right into that same GNSS folder and create a lots shape. And I did that earlier, so we're just going to overwrite that. And let's go ahead and export those. So we've just exported all of those shapes. Oh, I forgot to do something. Watch. Remember, we're at 5,000, 5,000. So I need to go back to my calibration, and because that was from NAD83 to local, I need to reverse it. I need to select it and reverse it, and now I need to export. And yes, I'm going to overwrite that. So not only did it export it, but it's going to show me what it did to convert all those points in the message view. Let's take a look at that. So it's going to tell me that as part of that process that it actually took 5,000, 5,000 and converted it to this coordinate position, which is the NAD83 position and elevation, before it wrote it to the shapefile. Okay, that's huge. That's huge. If I didn't calibrate it, I'd end up out in the Pacific Ocean somewhere probably. So let's drop into our EMLID flow now, and let's create a new project. Remember I said we're going to use Traverse BC to kind of manage a lot of this. Let's call this EMLID flow shape. EMLID flow doesn't have a quick way to say, oh, I imported the wrong points, delete them. I just can't manage points like that. And I've talked to them about it, and they said, well, we just can't do that. So we're going to do all that in Traverse BC. Let's do Oregon South as our projection, ellipsoid heights, and let's choose feet. Okay, so it's now created our project for us, and we need to do one more thing with that shapefile. We need to actually go in and select the DBF shape, the 4 files that are involved, and we need to zip those because EMLID can only read a zip file, which isn't uncommon. So I'm going to bring my zip over. We're going to say let's overwrite the file I had used earlier. I called it lots projection versus geographic. I remember we're still kind of testing all this, so I wanted to see what's going to work and how it's going to work. And let's add those files to it. Let's see if we can add those now. There we go. So out of all that, we get this lot projection zip file that it just created. So now let's go ahead and import that. Import. Let's bring in a shape file. Let's find our lots projected zip file. Bring it in. It's imported those. Now let's zoom out and see what we got. Now I'm going to refresh so that EMLID flow will create the line work. Remember I said we imported shapes. So let's get those shapes for us here. One of the things that's interesting about EMLID and shapes is that I don't get any arcs for the polylines here, but at least I get where the lot corners are all on the right-of-way for this cul-de-sac, for instance. So I'm real tickled with that. Now let's take a look at highlighting one of these lots up here. See how it highlights over here in EMLID? And I've got that lot in here as line L12. This is how EMLID handles their points. Here's all the points involved in that. Okay, so I've got access to the points, but now I have access to the line work for that lot as well. And I can come down and say, oh, what's this lot? Well, that's lot 13. And here are the points for that as well. Now, let's take a look at and see how this gives me what I want. I've got all the line work now that I can go in and use for staking out the lines. Also, I've got these a map versus a satellite layer. Sometimes it's kind of handy to look at one versus the other. I kind of like those backgrounds. I tend to work primarily in the satellite because I want to come in and say, oh yeah, here's the lake down here. I want to make sure the dock is in there. I want to see who's built on what lots, depending on how old the satellite imagery is. So I tend to like that satellite background, but this is what I get with the shapefile. Now, if you need to have some additional line work around these arcs or polyline bulges, in this case the cul-de-sac here, we can do that with the DXF, and we'll go ahead and take a look at doing that in just a moment. But let's drop back. Remember, this was all at 5,000, 5,000, and we simply said, I want to export that as a shapefile, and I'm going to use the calibration and reverse it and get exactly what I want. So it was as simple as simply saying, oh, I need to use an existing calibration that I've already brought into the survey. I need to reverse it so I go from local to NAD 83, and then I just export, and Traverse PC took care of all the rest of that. It gave me information about what it did in the message view, so I know how each point got reverse calibrated before it was exported as a shapefile. Now let's do the same thing with DXF export, because remember we said we wanted to get those curves in there, or those arcs in there. So exactly the same steps. I'm going to right click, Tools, Export Drawing As, and I'm going to export those 18 tagged items, or I could just do the drawing. Let's try the drawing here. Entire drawing GNSS export. This time though we're going to write an AutoCAD at DXF. I'm going to go in and pick some of the settings in here. One of the new features we have is omit paper space objects, so I can just get model space, which is nice. And then here's that same calibration option. I'm going to choose the calibration, reverse it. Now I'm going to choose the file I want to write, and I'm going to go into the GNSS, and I called that lots DXF. Let's replace that, and let's export it. So we just wrote out that DXF file. Let's preview that in the CAD view and see what we got. See what our coordinates are here now? As I watch the status line, I'm at state plane coordinates. And I want to just check something here and see if it turned out this way. Yeah, okay. You know what I just selected here was a polyline. So I didn't write that traverse out as lines and arcs. I wrote it out as a polyline because that makes it a lot tidier inside of EMLID. And the way I did that as a polyline was that any of these traverses, when I go into the traverse drawing settings, can be set to write out as a polyline as opposed to lines and arcs. So I just selected all of those lots. Okay. Selected my boundary. Selected my streets down here. I right-clicked one of them and said, hey, I want to go into the traverse drawing settings, but I only want to do control points and polylines. Wouldn't have to do lot labels. So now every one of those traverses that I've selected here is going to draw with continuous polyline as opposed to lines and arcs. And I'm going to get point labels and whatever symbol I chose or whatever. Okay. So that's how I created those polylines. So let's go ahead and import that into EMLID now and see how EMLID handles that. So remember I said we manage the projects in Traverse PC because we can handle all the points. I can't go in and just delete all those points I imported earlier into that shapefile. It gets kind of busy and time consuming. So I just come in and create a new project instead. Let's call this Sunset Cove DXF. Everything else is going to be the same. I'm going to choose Oregon South. Make sure it's in feet. And this time we're going to import a DXF file instead. So let's choose our file. Here's that lots DXF that we just wrote. And now we've imported all those DXF points. Let's refresh this so it'll create the line work. This is something they don't do automatically. Okay, now we've got our lines. And this is a little bothersome. We've talked with the engineers at EMLID and said, this is an awful lot of line segments for that arc. Could we get fewer line segments? They don't have that capability just yet, so we're kind of stuck with a lot of them. But look, I probably have my stakeout points ready to roll for this, and I can just pick whichever points I want and use that for stakeout. So a little different as far as the shape versus the DXF, but watch what happens when I select one of these again. Here's my line 12, so that whole lot up here is represented by that line in Emlid. So I could work at staking out the line work anywhere along here. The simpler ones are going to create simpler lines. Let's pick this one. And we're going to have just what, 5 points? 1, 2, 3, 4, 5. Yeah, the 4 points and then a closing point to close that out. So I get kind of the same information. I can go via DXF or shape. I get a little bit different results inside of Emlid. And we'll continue to work to kind of make sure we understand exactly how we can get the best results with Traverse PC. And we'll encourage and push Emlid to make any changes that we think will help us do this a little better. So let's kind of drop into the seminar where we talk about this workflow we're going to use to calibrate the GNSS to local and see how that works. Now we're going to repeat a lot of the steps that we did in the last webinar, but it's good. I mean, it's a similar workflow. We can repeat that workflow over and over and over again. We're going to take a look at how we do that. Let's come into Emlid Flow and let's clean up those projects that we just did a minute ago. Remember I said we tend to manage those projects with Traverse PC, and I find myself fairly often just deleting an Emlid Flow project and starting over from Traverse PC with just the data that I want for whatever I'm doing. So I'm going to delete that DXF. I'm going to delete the shape. And I'm going to create a new one called Sunset Cove Webinar. Now, probably the easiest way for me to show you what we did is to tell you that we're going to come into this map and print this out because I've got point labels on here, and I want to use these point labels like RPN for this northern reference point. This intersection of the street center lines is 10,092. I need those point labels, so I'm going to print this map out, and then I'm going to go out in the field and start occupying those points and coding those in the description. So I want to drop into Emlid Flow to kind of show you what that looked like. And I can show you by simply importing back in the CSV file that I exported from Emlid. Let's go out and get that file. So here's the GNSS. Here's the file that we exported. Let's just bring that in now to Emlid and back out and see what we did. So remember, I can use the street map and see that I got a reference point, a monument in the north cul-de-sac, a monument in the southern cul-de-sac, a monument at the intersection of these two streets, and then I picked up some additional lot corners. I was interested in lot 9 because that's the project I was going out on, so I got all the corners of lot 9. And you can see I'm back in the trees here, kind of down in a hole here, and still got a fix just fine. I also wanted to pick up one of the lot corners down here because this is a lot that had been excavated, and this was at grade. So this particular corner, they excavated to grade at that monument. So I just picked up that monument, and I know I've got grade now. And then I've got enough points here now to actually create a very nice calibration. So what did I do? I printed this map out, went out in the field. Out in the field, I occupied those monuments, okay, and I just, because I had a fixed location, I got the information right away. And let's take a look at what those look like. So here's my RMS values. Remember I said we're looking at centimeter accuracy, which is 3/100 of a foot, so I'm right in line with those. And then this is the workflow that we talked about earlier. We're going to just cover again today. Point 1 in the GNSS, I went into the description on my phone as I recorded the point, said equals RPN. So I wanted to know that I picked up this RPN point up here with GNSS point 1. And I'm going to do that with all of the points right on down the line. So everyone's got an equal 755 equals 10,048 equals 761 equals 763. Okay, see how I'm doing that? Every one of them, there's that intersection, and it shows me, as I select the points, right where they're at. Okay, there's the RPS south. I like having that kind of interaction like that. Pretty slick. So I've got all the points, and that's enough. We generally say that for calibrations, we want to encompass the entire area if possible. So if I could have gotten over here and gotten one more shot over here on the west side, that would have been good. But I felt pretty comfortable that I had enough out of that. So this is what I did in the field, and my phone looked just like this. I mean, I have the same application on my phone, and so I can pick up the points, see where they land, either on the satellite view or on the map view as I'm collecting the data. And back in the office, whoever's running emlet flow for this project sees those same points. So real time while I'm collecting those, because I'm on an N-trip network with a hotspot, the Wi-Fi puts those points up to the cloud, and they show up in this web app in the office. Kind of neat. Okay, so let's come into Traverse PC now, and let's import those points. So I'm going to go File, Import. I'm going to choose the emlet CSV. Now, there's lots of data that comes across for each point in an emlet CSV file. So one of the things we've done in this release, 2023 R1, remember I said we're looking at where are sort of the gotchas and the things that are hard to maneuver. Well, we said, let's go ahead and read this sequence right out of the header file. So we're going to take care of all of that for you, and you just say, get the format from the header. You don't have to type that in. Now, if you're using a receiver other than emlet, you can come in and change these to whatever you want. Okay, so the attributes are not going to be designated by a code header, but maybe by an attribute header. And then you can save and recall those files. And we've got a new header section in the program data, just like you have templates and legal description templates. We've got one for header. So if I create a header file and it works, I can share that with the other people in my office who use that same equipment. So really nice for just kind of making that all work. But I want to show you that I'm going to let Traverse PC read the format from the header. I'm going to add points to a traverse. I'm going to get details. And then this is important. I only want fixed solutions. If I was out there and didn't get a fixed solution on a point, I just want to ignore that point. I only want the readings where I got a fixed point, because that's where I'm going to get my accuracies that I'm interested in. So I'm going to tell Traverse PC, yep, that looks good. Let's go ahead and browse to that same file we just looked at in emlet a moment ago in GNSS. Now, some of you will take a look at this and say, well, what's in that? If I just open this up as a notepad file, and I'll show you real quickly so you aren't kind of afraid of what's in there. Here's my GNSS points, 1, 2, 3, 4, 5, up through 12. Remember, we said equals RPN equals 755. And then here's all the data with that. The RMS values, the Latin long, the coordinates. And I'm going to make one more change before I import. And that has to do with the label modifiers. I want to have the imported points be GNS1, GNS2, GNS3, GNS4, because I already have points 1, 2, 3, 4 in the survey. So this is just a real easy way for me to sort of create a whole nother set of group of points, and I don't have label conflicts with that. So that's what that label modifier does for me. And let's go ahead and import those. So Traverse PC is going to bring all those in, and I like the fact that in this message view now, I have all the information. So here's that GNS.1. So we modified the label from 1 to GNS1. Here's the description equals RPN. Here's the lat long and the height, and Traverse PC converted that to state plane coordinates using the coordinate reference system NAD 83 Oregon South and an elevation. And then here are my RMS values. So I know that, yeah, that point is centimeter accuracy. Here's the start and end time. I actually took 51 observations because I occupied that. I can't remember what it was, 5 seconds or 10 seconds, whatever it was. And then here's the base. So my base is 5.393 miles away, and it was using the CRS NAD 83, the 2011 epoch with Oregon South, just like I expected it to. So I'm going to print this out and stick it in the file folder because that's where how I got my points for this. Now let's come over to our traverses and let's take a look at our imported traverses. So here's that traverse that we brought in. Let's go ahead and tell Traverse PC we want to look at this using GPS 3D, and we want to look at this with imported points, but we're going to change that formatting because we want to have descriptions along with the point labels, and we want those to be just a little larger. That looks good. Let's open up that traverse and let's see what we got here. Okay, so here's my GNS1 equals RPN, GNS2 equals 755. Okay, see how that works? Now, because I had used this site survey earlier, site calibration, for geodetic points, do you see what it did with these points when it brought it in? They are now at my 5,000, 5,000 coordinates. In fact, if I chose to plot this, see where those points show up? Right over the top of what they should. Now, originally I'm not going to have that site calibration in here, so I'm not going to have that available. But I wanted you to just see real quick that that's kind of the beauty of a site calibration, is that it reverse calibrated when it sent my points out to Google Earth, so they would be geodetic positions. And when I imported geodetic positions, it forward calibrated it to my 5,000, 5,000 coordinate system. I didn't even have to think about that. So this is just kind of, I don't know, I think it's kind of absolutely amazing how that works inside of Traverse PC. It's pretty slick. But I want to walk you back through the steps of creating that calibration. So let's take a look at how we do that. I go to Calibration, create a calibration, and this is the same structure we used in the last webinar, except I used the reverse option down here. So let's take a look at this. This says select a traverse of uncalibrated points. So the GNSS points are the uncalibrated points, with calibrated points as, we're going to include them in the description with an equals. So my calibration, I want it to go from the GNSS position to local. So I'm going to select this. That's what it says. If I wanted to go the other way like I did in part 1, I just reverse that. Okay? And it automatically looks for them in the opposite direction. This way, I'm going to use a traverse, and I'm going to come in and select the traverse. It's the one I just imported. And choose OK. So Traverse PC just created that calibration for me. And let's take a look at it real quick. I didn't get any data here, so let's cancel that. I've got to turn off that site calibration first, or I won't get what I want. So let's come into our site calibration, tell it we don't want to do geodetic points, and let's choose none just to turn it off. Okay, so now we have our northing and easting back at state plane. Otherwise, we're not going to get a calibration generated properly. So now let's create our calibration. Everything's just fine. Let's go back and select that traverse. Now I've got what I want. Okay, so what are we looking for? I'm looking for this TX and TY. Those are my X and Y translations. I expect those to be big, right? Because I'm going from a state plane in Oregon South, which is 800,000 and millions, okay, to 5,000, 5,000. I'm looking at my rotation, and this version of Traverse PC displays both clockwise and counterclockwise. It's kind of hard to figure out what 358, 46, 13 is, but it's easy to figure out what 113, 47 is. And then I'm expecting some kind of scaling, but not very much. So 1.00007. And I'm expecting some kind of a vertical shift to get me to that geoid height. So I've really got what I want. It looks good. And I'm just going to document this now. So I am going from the survey CRS to local site. So these will be recorded with that calibration now. And I'm just going to come in and say, this is the webinar one. And I'm going to repeat that when I go to save it. So here's the GNSS that I did earlier, but here's the one I want to save for the webinar. Okay, I've created that calibration now. I could just as easily now come in and say, I want to use that new calibration for my site calibration. And let's come in and select that. And let's do geodetic points. And when I hit OK, there's my calibrated positions again. And if I tag that traverse, they're plotted right where they're supposed to be. Okay, so pretty neat. Let me pause there and look at my notes again. Okay, let's, in the interest of time, and leaving enough time for questions here, let's just kind of go unscripted. I'm not going to be able to jump in on these particular projects, but I want to show you where we're going next time we come back to this, and we'll just make this part 3. So here's the work we're going to do for the Lot 9 folks, and you can see that they've got this house stake out here. We had a couple of plans we were working with, so here's one I just drug off to the side a little bit. A couple plans they were working with, and we're interested in coming up with the sight lines to the lake. And we've got some vegetation restricting here on the north side. We've got the lake shoreline restricting on the south. And we said this kind of creates a corridor for this Lot 9. And remember I said Lot 12 is going to build. It could be that this Lot 12 house, if it's put back far enough, wouldn't even affect the line of sight or the sights from this Lot 9, depending on where we place this on the lot. But it is going to affect Lot 10 and Lot 5, and Lot 6 could see a little bit down through here, and Lots 8 and 7 could see a little bit through here. So we've got all these houses that are going to have their lake view affected by what happens on this Lot 12. So Lot 9 was kind of the first one to the starting line, and we're going to take a look at kind of how that fits. And we'll take a look at this plan view. We'll come in and take a look at this profile where we actually get a chance to see, yeah, if we put a ground floor house, what does it look like if we miss the top of that house with the way it's been excavated? And what if we build a 2-story or a story and a half? And how does that change our line of sight? And we can actually go out and look to see how far out in the lake are we looking for that one. The people in Lot 9 or Lot 10, they're going to lose their view of the dock no matter what happens. So we want to take a look at, how much are they going to lose on that. But we're going to do all of this exactly like we've done everything else. I'm going to come into this traverse here that created by they created this, and I'm going to convert that then to a traverse that I can go ahead and stake out. Let me just see if I've got that here under Lot 9. Okay, so under Proposed House Plans, we've got this Plan 4, Lot 9. Open that up, and if we take a look at just that traverse for that lot, get that out of the way. Okay, so there's the house plan. We just pulled up the points that create the perimeter for that. And we'll go ahead and take a look at, let's go ahead and export that to EMLID, just so you can kind of get a feel for what that looks like as we just repeat what we've been doing over and over again. So we're going to select just that one traverse under the Proposed House Plans. It's selected, and let's go ahead and pin that so we remember that it's selected. Then let's go to File, export, and let's send this to an MLID, CSV. We're going to send just the one traverse, Plan 4 Lot 9. We're going to reverse calibrate, just like we did when we did our shape files and our DXF. And let's go ahead and tell it where we're going to put this. Let's do Lot 9. And let's overwrite this Lot 9 Plan 4 CSV. Let's export it. No, we did that. There we go. So there's our 17 points, and it's did the calibration and told us how it calibrated them. Now we can go in to our project, and we could say import CSV file, and let's bring that in. And it's in Lot 9. So there's our Lot 9 house ready for stakeout, just like we want. And I could bring the shape or the DXF file in, so we had the line work all in here to make that look a little nicer. But that's how that calibration allows us to just keep working on this project and reuse that calibration over and over again. In this case, I just reverse calibrated the foundation at 5,000, 5,000, so it would be at the right place for my GNSS, and now I can use my GNSS receivers to just stake those points out. Okay, let's stop there.